Welcome back to my channel Talking Physics with Piyas Sarkar. Dear student, now we going to learn about the application of dimensional analysis. We know about dimensional formula, dimension and dimensional equation, but what is its application? So today we learn the application of dimension analysis and its first part. It has three applications. Today we shall only discuss the first part. So at first we go with the definition of dimensional analysis. So the method of studying physical phenomena on the basis of dimension is called dimensional analysis. This is the definition of dimensional analysis, the method of studying physical phenomena. Physical phenomena means all the phenomena occur in nature. So the method of studying physical phenomena on the basis of dimension is called dimensional analysis. So it has basically three applications. Number one is to convert a quantity or physical quantity from one unit to another, to convert a quantity from one unit to another. Number two is to check the correctness of a physical relation, of a given physical relation, and number three is to derive a relation between different physical quantity. These three are the basic application of dimension analysis. To convert a quantity from one unit to another. We know there is three types of unit: CGS, MKS and SI. FPS unit is not so discussed in nowadays, so we can avoid this. Number two is to check the correctness of a given physical equation. Suppose if equation is given, we check it either it is correct or not correct on the basis of dimensional analysis. And number three is to derive a relation between different physical quantity. We have to give in question some physical quantity and we have to say to establish a relation between these. So these three type of work we can do with dimensional analysis. But today we shall go with only with the first topic, to convert a quantity from one unit to another. In short, it is also called unit conversion. So we can go with at first theory, and then we can go with some numerical example which will basically clear your idea, and you will do any problem by using it. So let us start. Suppose a physical quantity has two parts. One is its numerical value and other is unit. Suppose in two different unit, the unit is into different unit, U1 and U2 are the system of unit used. U1 and U2 are the unit used in first system, and U2 is unit used in second system. Okay, and if N1 and N2 are the numerical values of that physical quantity, suppose we can say it N1 and N2 is the numerical quantity of that physical quantity, numerical values of that physical quantity in another system, then according to dimensional analysis these two must be equal. N1 U1 must be equal to N2 U2. This belongs to a certain physical quantity, suppose Q. So the value and the unit used in two different system is N1 U1 and other is N2 U2, and this must be equal. This is the basic formula to convert any physical value of numerical values of a physical quantity to another unit. Suppose the dimension of that quantity of a certain physical quantity is ml t minus 2 or ml t. Quantity is, suppose, m to the power a, l to the power b and t to the power c, where a, b, c are the values. A, B, C are take values 1, 2, 3, etc. And the unit of that quantity in the first unit is M1, L1, T1, that is M1 to the power A, L1 to the power B and T1 to the power C. And in second unit it is as M2 to the power A, L2 to the power B and T2 to the power C. Then we can write it as N1 into this quantity equal to N2 into this quantity. The dimension of that quantity is M to the power A, L to the power B and T to the power C. This dimension is independent of any unit, but the value of this quantity in first unit is M1 to the power A, L1 to the power B, T1 to the power C, and in second unit is M2 to the power A, L2 to the power B, T2 to the power C. So if we, and N1 is the numerical value of this physical quantity and it is given, we can find out the values of that physical quantity in another system. So we can get the values N2 equal to N1 M1 by M2 to the power A, L1 by L2 to the power B and T1 by T2 to the power C. Here M, L and T are not the dimension. We write it as dimension, but here the unit, here not is M, L, T. We know that MLT is the dimension of mass, length and time, but here MLT is not dimension, written as dimension, it is the unit. We can go with numerical example, then we understand it very clearly. M, L and T here is not dimension, here is the only unit. Suppose it is in SI unit, that is the mass is kilogram, length is meter and T is second. So this is the formula, you can write down it, that N2 is equal to N1 M1 by M2 to the power A is the value of the power, L1 by L2 to the power B and T1 by T2 to the power C, where M1 for SI system, M1 is 1 meter, M2 is for CGS system, that is 1 centimeter. If we convert it from MKS to CGS system, M1 is 1 kg, M2 is 1 gram, L1 is 1 meter, L2 is 1 semi and T1 equal to 1 second and T2 obviously 1 second. Okay. So this is the basic formula of conversion of a physical quantity from one unit to another. We shall go with from a very simple example. Suppose we have to say that what is the now we shall go with some numerical example of dimension analysis. Suppose the value of universal and gravitational constant is given as 6.67 into 10 to the power minus 11 Newton meter square kg to the power minus 2, that is in SI unit. We have to find out its value in CGS unit. How can we find out it? Okay. So as per the given relation, we first put out the dimension of G. So G is equal to, from gravitational law, Fr square by m square. F, the dimension of F, that is force, is mLt minus 2 length square by mass square. So the dimension of gravitational constant is m to the power minus 1 L cube T minus 2. So we can know the formula, N2 is equal to N1 times M1 by M2 to the power A, L1 by L2 to the power B and T1 by T2 to the power C. But here, ruk jao, we write it M1 by M2, L1 by L2, T1 by T2. That not means that M is mass, L is length, T is time. No. We have to use it as unit, not dimension. Okay. So we know the value of N1 is given. That is, this is the value of N1. 6.67 into 10 to the power minus 11. What is the value of M1? M1 is the, for this, M1 is mass. Okay. So mass is 1 kg by 1 gram to the power minus 1. Okay. Then L cube. Here is L is length. So here L is 1 meter by 1 semi cube. And this is not time. Or sorry, this is time. That is T1 by T2. T1 by T2. That is 1 second by 1 second to the power minus 2. Okay, minus 2. So 6.67 into 10 to the power minus 11 into 1 kg by 1 gram. The ratio is 10 cube because 1 kg equal to 10 to the power 3. So 10 cube by 1 to the power minus 1 multiplied by 1 meter means 10 square semi by 1 semi cube into this is 1. So 6.67 into 10 to the power minus 11 times 10 to the power minus 3. 10 to the power minus 3 times 10 to the power 6. That is 6.67 into 10 to the power minus 8 dyne semi square gram to the power minus 2. Okay. So we can easily evaluate the value of universal gravitation constant in CGS system. I hope you understand it. If not, then please comment me in my comment box, or if you like, please press the bell icon for new video and subscribe my channel. Next we go with the another example. So you can check in your home that one arc, that is the unit of energy, equal to how many joule by the unit conversion. This is your homework. Try it in your own way. Next we shall go with another example which is different from this, but it's also included in our dimensional analysis chapter. That is, if the energy, velocity and force be taken as fundamental unit, if energy, E, force, F and velocity, V, taken as fundamental units, then dimension of mass will be. Velocity is taken as Fu, that is fundamental units, then find out dimension of mass. We know that fundamental quantities are always mass, length and time, but in this question we have to take fundamental quantities energy, force and velocity. So we have to solve it from dimensional analysis. How can we solve it? As we know that energy equal to half mv square, so dimension of mass equal to E times v square or E v to the power minus 2. But this is not, we can write it straight, but this is a not true procedure. Okay, from dimension analysis we can try to solve it. So we know that the dimension of E is ml square t minus 2 and dimension of velocity is L t minus 1 and dimension of force is ml t minus 2. If we divide E by F, what we can get? ml square t minus 2 by ml t minus 2. So we can get dimension of L. So dimension of L is given by E by F. Okay. Now dimension of V equal to L t minus 1. So dimension of V equal to L t minus 1. So L is written as E by F t minus 1. So we can get Fv by E is equal to t minus 1, or we can get t equal to E by Fv. So we can find out the dimension of L and T. So from any two of this equation we can find the dimension of mass. So we can get dimension of mass equal to E divided by L square t minus 2 or Et square by L square. Now E is as fundamental quantity, we write it as E. T square, what is the dimension of T? We get E by Fb, that is E square by F square V square, E square by F square V square into divided by L square, divided by L square, divided by L square. L means E square by F square, E square by F square. So we can get E into E square by F square V square, and this times will be opposite, that is multiplied by F square by E square, F square by E square. So E square cancel out, F square cancel out. So we can get E by V square, that is E v to the power minus 2. The same result that we obtained from the half mv square formula. Okay, this is the exact way of dimensional analysis, that if energy, velocity and force will be the fundamental quantities, then the dimension of mass will be Ev minus 2. Okay. Next we go with some another example. If you like my channel, please comment so that I can encourage. Okay. Otherwise, I don't know whether you like it, my channel or not. Okay. So next we go with the third example. इसके बाद we will go for one dimensional motion, that is motion in a straight line, and it's all numericals. So keep watching my channel, keep watching my video. Okay. Now we go with the third example, that is in a system of units, the unit of mass, length and time bar in a certain system of unit of mass, length and time are given. Mass is 1 quintal, length is 1 kilometer and time is 1 hour. Okay. Then 1 Newton force, the value of 1 Newton force, will be how much in that new unit. Okay. We know that Newton is the unit of force in MKS system or SI system. But this is, we can say it QKH or anyone, or we can name it a new unit. Okay. So here this term will be L1, M1 and L2 and 1 Newton. Newton is the force. So the dimension of force we can write MLT minus 2. Okay. So we again know that the N2 is equal to N1, L1 by L2, here M1, M1 by M2 A, L1 by L2 B and T1 by T2 C. So N1 is what? 1 Newton. 1 Newton. What is M1? M1 by M2. M1 is 1 quintal. No, sorry. As N1 is 1 Newton, so we can find out the value of N2. That is the value of 1 Newton in this quantity. So this will be M2, this will be L2 and this will be T2. Okay, because we have to find out this quantity in a new system. So M1 here is 1 mass, that is 1 kg, and M2 equal to 1 quintal. To the power A means 1 multiplied by L1. L1 is how much L1? L1 is 1 meter divided by 1 kilometer, that is L2. No, to the power 1 of and T minus 2, that is 1 second divided by, in new unit T is 1 hour. 1 hour, that is 3600 second to the power minus 2. Okay. So 1 Newton multiplied by 1 by 1000, because 1000 kg equal to 1 quintal. 1 meter by again 1000 into, this is to the power minus 2, that is 1 by 3600 to the power minus 2 means 3600 to the power plus 2. Okay. So if we put this value, we can get it 12 point, you can get the value of the new force. We can get, you can use the calculator also, 129.6, 129.6 new unit, we can say it new unit. Okay, 129.6 new unit. So here M2 is the unit in which M2, L2, T2 are the unit in which we have to find out the value, and M1, L1, T1 is unit in which this value is taken. As here this value, that is Newton value, is known, so M1, L1, T1 are the value according to MKS system. But we have to find out the value of N2, that is in the new unit. So these are M2, L2 and T2. Okay, I hope you understand it. So in this way, we can apply unit conversion method from one quantity to another quantity. Next day, we go with the second part, that is the correctness of a physical quantity or physical relation or physical derivation. Okay, if you like my video, press the bell icon and subscribe my channel for new learning video. Thank you.